So last time we were working on unit 2, and I'll slide down a little bit to show you exactly where we stopped the last time. Had a lot to do with functions, talked about algorithms and the various characteristics of algorithms, and then we talked about pseudocodes, flowcharts, how to set some of those up. And this is like giving you some background in computer science generally. All of these apply to all kinds of programming, irrespective of what language you are using. So, but very importantly, one of the things we zeroed in on the last week was functions. And I did mention that functions are self-contained blocks of code used to perform a specific task. It's almost like, and I think that's why I brought this, when you are trying to do modular housing or something, right? They are literally blocks that you can piece together, right, to build a program. I'm going to talk a little bit about that this evening before I proceed into a couple of other things that we're going to do. So in a sense, I'm going to try to round up chapter unit 2, even though there are a couple of elements of unit 2 that we might come back to later. So whenever I do send back a slide of unit 2, that literally means that there have been some updates to that slide, because there are certain things I really don't want to jump into so that it doesn't confuse people, especially people that have no programming background. So here we talked about the typical syntax of a function, right? How to do function declarations. And if you've gone through some of the exercises, you would have run into examples of how to set up the functions and also how to do the calls, which is what you call a function call. But this is where I intend to start today, right? I mean, this is this beautiful song, that has spanned decades, a very popular Christian song, right? And it's this song about how great thou art. How great thou art, how great thou art.
I told you it works.
I got someone's voice. Okay, so this is a popular song, right? That is sung and has been sung for maybe hundreds of years, very popular. But one of the things you see is the song contains a chorus, right? And the chorus is taking up all of the place. Notice what you have here. This is the chorus of what you call your refrain. This is it here. So you sing this, you sing this, you sing this, you come back to singing this again, sing this, and you come back. So it makes it very clumsy to have, and that's typically what happens when you write your program, right? Sometimes there are certain elements of the program that you have to repeat over and over again. So why would I have to keep repeating all of this everywhere, right? One way to solve that problem, right, is what I'm going to show us that is done in music typically. So, and I would also say in programming, right? So you have, assume this is a body of code, right? So one of the ways I could do this, so this is what you call like a refrain in music. One of the ways, or in programming, you would call this a function, right? So I could decide, hey, I'm not going to keep repeating myself all over the place. I'm just going to leave this guy here, right? Just sing this, come sing the chorus, go sing this, come back, sing the chorus. And all I need to do is just say, this is the refrain, and then I show the refrain here. So whenever you hit on this, right, you should be singing this. Whenever you hit on this, you should be singing this. So literally, that's how functions work, right? That's one way of doing it, where, for example, you put the function in the midst of the main file of the program. Another way of doing it is literally doing something like this, right? Where you actually remove the code, which is the function, and save it as a different file. You name it whatever the name of that function is. And then you have your main file, and you put both of those files, right, in a folder. So whenever your code, which typically runs from top to bottom, begins to run, it runs to this point and then it makes a deviation. This is typically what you will call a function call, right? So your program begins to run. Once it hits this obstruction just says, hey, jump out of this file, go into the next file in the folder that is called something. Let's say the name of the file is called refrain. So that means this function will be called refrain, right? It jumps in there, executes whatever is there, and jumps back here and continues. When it hits another roadblock, it jumps in, executes, comes back, something like that. So that's literally how functions work. Now, function, like part of what I'm going to be doing today, right, as we step into Unit 3, is discussing, in the beginning of the class, I had actually discussed some of those. I want to think it's in this slide, where we talked about different kinds of, okay, no, I think it's in Unit 1, where we talked about different kinds of different types of different data types, right? Where we talked about things like character, string, integer, boolean, and all of that. So function is also a type of, it's a data type, or what you would call in programming a type. When I'm through with this, I'm going to go through and show us using some kind of flow chart or some kind of chart, right, to show us the different kinds of types or data types. Now, and then one of the things we are going to be doing as part of the class is actually helping us get acquainted with each of those types and the way the types behave. Now, some of the types that I talked about in a previous class, right, which were character, string, integer, double, you name it, Boolean, all of those are what you will call like your fundamental or the primary data types in Swift. But then there are more advanced data types, right, that we would also that we're going to be talking about, and one of which is functions. And essentially, a few slides back, I literally showed us what functions are and what you do with functions. And all it is you have this keyword, right? Once the code or the compiler sees this func, it automatically knows that this is a function. And every type, right, has properties and methods, the way they behave, right? So once the compiler hits on this func, it automatically knows, hey, this is a func, so I'm going to treat it like a function, right? And then all it does is, this is the name of the function, and then these are the parameters, right? So you have the parameter and the type, which is the data type, the parameter and the data type, and then you have this sign, which now opens up this brace, right? And within the brace is where you have your expression, which could be the code, the code, remember the code? So this is literally like the code. That's what you're going to put within those braces so that stuff begins to run, and then it executes, and then it gives you some kind of output. So a function literally gets some input data from you, processes it within the parentheses, and then outputs that result. For example, this is the return, which is the output, right? It outputs that result so that you can. But notice that this is written in a generic form so that I can easily make a call, right? And what does making a call means? It simply means now I want specifics, right? instead of just int, right? I want to be able to give specific instances. And today, later today, we're actually going to talk about instances. So if you don't understand what I mean when I say instances, I'm going to break that down. Like I try to break this down to as elementary a level as possible so that you can actually understand, especially for those that have no background in this. But my whole point of talking about functions in the way I've talked about them now is just for you to understand that they are a data type, and that every data type, right, has parameters that they receive and they output. Remember, programming is literally about receiving data, processing that data, and outputting that data. And different data types, right, have specific ways they accept data, process that data, and let that data out. So functions are an example of a data type. So I discussed why we do functions, and try to use music to explain what it is that functions do. And then the next thing is the issue of making decisions, right? For those of you that have done some kind of programming elsewhere would understand, conditionals, right? Making decisions, how you make decisions, uh, which is you have things like if statements, the if else statements, else if statements, which is literally like if this happens, then do this. So you are literally creating a process where you accept data and then you create conditions along the way, like stops, right? Where if you get to either of the stops, right, you have two or more ways to go, right? And what direction you go depends on you meeting certain criteria, right? So all we have been doing before now was just straight up programming where you come from the top and run down. But life doesn't really work like that. Sometimes we typically as humans, right, run into situations where we have to make decisions. So conditionals, right? And then comparison operators that we're going to see are one way, right, that you can use in codes to be able to establish or build in those abilities to make decisions. So one of the ways to start, right, and for those of you that have done your exercises, it will be very easy for you to understand this, is talking about comparison operators. One of them is you have this equality operator, or what you call like the double equal sign, which literally says one and then equal to this, right? That's completely different from your equal sign. Just remember that, right? Your equal sign is literally used as a way of assigning stuff. So if I say x is equals to 2, I'm just trying to say that x, right? I'm assigning x a value of 2. So because that equal sign has been taken, I talk about in all of these programs, sometimes there are certain keywords or certain operations that have been, appropriated, that's the right word, appropriated by the program. Now you can't use them for any other thing. So the equal sign is literally a way of assigning value to a variable or a constant. That's all it is. It doesn't mean equal to in the sense that we know it, right? So a replacement for that is where you have a double equal. So when I have a double equal, right? So if I typed in this, for any of you that is on Playground, if you type in 1 equal to, it will give you, the answer is going to be false because 1 is not equals to 2, right? And how you test that proposition is by using your double equal sign. So if I type something like this, 12 is equals to 10 plus the double equal to 10 plus 2, Playground is going to tell you yes, right? Because this is actually 12 is equivalent to 12, which is correct. So it will be true. So this is one of those tools that you use to perform comparisons when you create programs. And then, of course, all of us will be familiar with all of this. We have the less than sign. So if 100 is less than 1,000, if you run that in Playground, it's going to say yes. Why? Because actually 100 is less than 1,000. So it should say true. So it's like a Boolean type arrangement, a yes or no, yes or no. So all you're actually trying to do is to make comparisons. And then these are other symbols that you actually use for making those comparisons. So the sign you have here, actually literally means not, N-O-T, which is not equal to. And this is less than or equal to. In some cases, you're trying to test something to say, oh, it's greater than or equals to. Let me see, someone asking a question. Can anyone see where he's pointing? Oh, can you guys see where I'm pointing when I'm talking? That's my cursor. Can you? Or do you see this? I want to know what screen. I'm using two screens. Okay, I think. Oh, I see. So it's probably better to use this screen. So this is where I'm pointing to right now. Sorry about that. So, right. So the next is the if statement. What exactly does the if statement do? Right? It's very simple. This is not as written out as I want it to be. So your if statement, what does it do? Right? It's like, let's say we have like your let video length. This is your constant, remember? This is like your constant. Let the video length equals to 5. Now, what I'm trying to ask is if the video length is less than 5, then do this operation, right? Again, the next thing is if. So all I'm trying to point out here is all you have is if, and that's how the if statement behaves. So there is no alternative except the conditions that have been predetermined, right? So if I'm going to use the if statement, then I must be working with predetermined conditions. Anything outside that boundary would not work with an if statement. Again, the way for you to really understand this is to go to one of those exercises and run those exercises. So that's like your if statement. The next is your if else statement, right? Which is literally let so and so. So for example, let video length. We're trying to talk about the length of our video is say 5 minutes, right? Let the video length be equals to 5 minutes. So my question is, if the video, sorry, there's supposed to be an O here. If the video length is less than 5 minutes, right? Then print out this statement. Else, right? So anything that contradicts less than, which means equal to or greater than, then print out this. So it's your way of controlling the behavior of this program. So what you have here, right, where you're using conditionals, in a sense, is what I'm going to call like the behavior of your program. Eventually, we're going to see that later when we get into Unit 3, where you're giving your program the ability to manipulate data and respond to different stimuli. Now, depending on what you throw at it, it behaves in a completely different way. That's the behavior of your program. And when we begin to talk about structs and we begin to talk about classes, you're going to see how the behavior can be built into a program so that it does the things you want it to do. So it's not just that you're introducing data into the system is also manipulating that data to behave in certain ways. So this is a typical example of that. So this is more or less what you call the else if statement. Notice there's a difference between this, right? You just said if and then you jump to else, right? But in this case, you have your another length of video, 7,500. If another length of video is less than 5, then do this. Let's say print this statements. Else, if it is greater than 500, I need you to do this. Else, do this. The only condition that is going to happen here is, so what this has done is it's created a bound between less than 5 and greater than 5. So you can create multiple conditions, right? And then the final else just says any other thing that doesn't happen here, happens here. In other words, you're literally operating from this point to infinity. This point creates an opportunity. What else does is that it creates an opportunity for every other thing to happen that's outside your predetermined boundaries. That's what makes else fascinating and very important. So because some of these I actually picked them up from the exercise. So again, it's very important that you go do the exercises. And because it's online and because of the way we are spread, there are a whole lot of things I really can't do like I would do in a typical classroom. So go try them out. If you run into any problems, email me. I can set up a video call with you and we go through all of those. But just notice what's happening here when we talk about compound conditionals. All it's just saying, nothing complex, but all it's just saying is, hey, it's not just, I'm trying to begin to use, to expand the boundaries of what what I can do. So I'm saying, I'm defining a number of parameters here. Let's band member count, the number of band members equals to 5. Let the weight per person equals to this. Let this equals to this. Let this equals to this. Then I now multiply this times this, that times this, right? And I'm going to get some kind of value. And then I said if the gear weight, right, which is this gear weight, if it's literally like saying if 450 is less than the total carrying weight, and the program, because it runs from the top to the bottom, is going to pick this value, multiply it by this value, multiply it by this value, and give us some kind of value. Hypothetically, let me just assume it gives us 900, right? This condition says if 450 is less than 900, it prints rock on, else it prints this. So it's getting a little more complicated. That's just what compound conditionals are. Remember where we were talking about the test where you have the double equal sign, right? Not equals to. Those are the points where you actually begin to use some of those conditions to test a whole bunch of propositions using if, else statements, else if statements, and all of those kind of statements. And as you practice, do your exercises, that's when you're actually going to quickly begin to see the various situations and what differences exist between them. So this is another example. And these are other ways, right, where you can actually test conditions. So something like this, right? The Boolean OR operator. So when you have these two lines, it literally means OR. And so false and false. That's what this means. False or false. Sometimes in trying to test certain propositions, so one of the things probably I would suggest is once you get off here, or if you're able to do it while you're logged in now, just go to Playground, type false and false and see what result it gives you, right? And then you try with false and false, false and false, and false or false, and then it's going to give you some results. Why is this useful? So let's say I'm testing a proposition, right? I say 3 plus 2, right? And 5 minus 2, right? I'm trying to test whether the things on the left-hand side, right, and the things on the right-hand side, right, if I join those two conditions, what is going to be the output, right? Like I say, Peter and John, right? Peter and John is going to give me 2 people, right? Peter, John, and Andrew is going to give me some output, 3 people. So this is your way of making those connections between two or more entities, especially when it's a Boolean operation. Remember, your Boolean operation is like 0, 1, false or true, false or true, false or true. So like in elementary math, right? You have something like plus minus is equals to minus, minus plus is equals to minus, minus minus is equals to plus, plus plus is equals to. It's almost something along those lines that's happening. So I think I'm going to end with this. So the other thing I'm going to go talk about is the bougie bot. That's the dancing robot. It's in the exercise. And I think I'm going to try to, just a minute. I am good. Admit all. Sorry about that. So I'm going to try to see if I can use my other laptop to open up the exercise and then run us through a couple of things in that exercise. And before we proceed, and the reason I'm trying to do this is to emphasize how important doing those specific exercises are and what specific skills, right, it's going to build, you're going to develop. Because if eventually when we start working in Xcode, right, some of those skills that you have built from, say, the dancing robots and all the other exercises, I'm going to show us how useful those are going to end up being for us. So just a moment, let me try to, this is bouncy ball. Give me a minute. Building. Let me see where that is. So that's algorithms playing with programs, bougie board. Yep. So I'm going to share the screen. Just a minute. Okay. Okay. Just so if you're close to your, if you have your system, I would actually suggest you open this alongside with me. If you go to your program and check, I'm talking of the exercise now. Remember the exercise, the folder that has all of your exercise, right? Where you have unit 1 to 4. Now you can go to unit 2 for the exercise. If you remember the exercise where you have all your files, your practice files, right? You go to algorithms, and then when you get to algorithms, then you go to your subfolder, which is play with programs. And if you want me to repeat that, just type in in the chat and I will repeat it. But I will, let me stop sharing here and resume sharing on a different laptop. So can you see my screen now? I don't know if you can see my screen. Yes, no? Hello, sharing is paused. Okay. Okay, just a minute. Okay, just a moment. Sorry, that's me trying to use a second laptop. So, sorry, it's taking some time. Okay, yep. So, this is what I was referring to. Now, if you, it's going to be something like this. This is what you're supposed to have, which I think for everyone that has been doing the exercises, you're going to see this folder. That's where all the files are. And then you click algorithms, then you click play with programs, and this is where I am referring to the playground program, right? So I'm opening that up, and that's what I have here, I think. So if you're looking at me, you would see this. So I just want to run a couple of things by us. So this is a very interesting program, I think, that is actually going to be very helpful. Now, one of the things it does is it deeply illustrates the concept of functions and how functions actually become the building block of programming, right? So as you look at that robot moving its hands and legs, all that's going on there is all functions, right? And I'm going to run us through this exercise. Um, for those of you that have already gone through the exercises, it's going to help reinforce what goes on in programs, because eventually when you begin to use your Xcode and you're trying to develop an app, it's just these are like the little primary things that you're going to be doing in your actual code. So um, I would start by probably moving to the next. So look at this, right? So everything you see here, left arm up, right? Left arm down, right arm, all of what you see, right? So first of all, this is how you start the app. You say start bot, right? At the top, this, that's how you start the app, right? But one of the things I like you to reflect on is each of what you see here. These are actually like function calls where each of them is a function. Remember the music analogy that I gave to us, and I said that was refrain. Each of these is like the refrain. So the code is somewhere in the folder somewhere, right? All you're doing with each of these is just calling up those functions, calling up each of those functions. So these are all a bunch of functions that are being written by some other fellow somewhere, right? All you're doing is just calling up these functions. So um, I can arrange each of these function calls in any number of ways. All that's happening is the code will begin to run. It will start running from start bots, and then it will go to the next line, which is a function. And then a function call happens, and it executes whatever it's been asked to do. And then it moves to the next thing, and it moves to the next thing, and it moves to the next thing. Remember our naming convention where you start with a small letter, you know, capital letter for the second word, and all of that. The second thing to notice is that see how descriptive these um, words are. Each of them are so descriptive that you can just look at them and automatically know what they mean. Right. Now, when you have a congregation of all of these functions working together, right, to be able to solve a problem, right, that's literally what you now call an API. It's an application programming interface. So one of the things that will be happening as you begin to build codes, especially when we go into more advanced parts of the programming, is all of a sudden you might be using APIs. Again, remember, your APIs are a bunch of related functions, right, that can work together to solve a specific problem. That's what APIs are. And all you're doing is literally making function calls to wherever they are to pull their capabilities or their abilities into your code to be able to solve a specific problem. Because you really cannot solve every problem in a code that you want to solve. So functions are a way of you reusing some codes that you have written before, or using the codes other people have written so that you don't have to go recreating the wheel over and over again. And what we have here is literally how you make that call. So I might have an ability to solve some kind of problem. I put all of that together. It's like your Lego, right? Lego sometimes they don't have any specific thing in mind that they want to build, but they have all of these parts put together, and each of those parts are like what you call the functions, right? And then the whole box put together is your API. I hope that really gets it. So now, for this app, you have a number of functions. There are a group of functions here that all they do is help move the right hand up and down. Then there are another set of them that helps the robot shake left or right, center, jump up or jump down, and fabulize. Fabulize has to do with coming a light, right, shining up or dimming, right? So we can literally tell this robot to do all kinds of things, right? So this is, notice how this is arranged, right? We decide, okay, we're starting with the start birds, and then we come here and then we say fabulize, right? Fabulize, and then, so all we're just doing is we're lining up all of these to have it behave in a certain way. So let me see, just a minute. Editor, okay, live view, right? So notice, okay, sorry, I'm gonna run this now. See what it's doing? All it's doing is simply going, sorry, all it's doing is going from line to line. That's all it's doing. It's reading the code from line to line. Let me make it keep automatically run. Okay, so let's assume that I decide to remove, let me see, what do I remove now? Okay, let me run it again. Just pay attention to what's going on. See what's going on? Now notice the waist is moving. The waist moves. Just focus on the waist. See how that waist moves? Look at it again. Focus on the waist. See how that waist moves? Then I can decide, you know what's making that waist move, right? These two functions, right? Shake it left, shake it right. So I can decide, you know what, I'm going to cut out shake it left and shake it right. So let's see what happens, right? And then I run this guy again. Notice the waist isn't shaking anymore. The waist isn't shaking anymore. Why? Because the function that makes this. So my whole point is to illustrate the fact that I put that back, right? The waist is shaking back again. It's just to illustrate the point that the programs you're going to be writing at the end of the day is going to be made up of blocks, right? And there are all kinds of blocks. Again, part of what I'm going to show us in the next unit, right, is going to be the different kinds of block, and function is one type of those blocks, right? And all of these are functions, and a conglomeration of them is what you literally call your APIs. So this is what is discussed here. So it says app developers always depend on code written by others. In the case of Bugio bots, right, a number of functions are defined that make Bugio bots start, move, and change colors. So the API is a specific set of functionality that a software developer can use to accomplish a task. In this case, the Bugio bot API is making a software robot dance, and this is what we have there. So a couple of other things. So point being that if you haven't done this, it'll be a good opportunity for you to go. Now, notice what else is happening here, right? Now, beside the fact that all of these are functions, right? Whoever created this exercise decided to create another function, right? And put those functions into another function. Notice what's going on there. Because func is me trying to create a function. So I said func, and then I decide to say, hey, do this disco, right? I've created a set of steps I want this guy to do, and I put them into a function, right? So I've created this function. Now, if I was trying to do all of this, it'd probably be 2 or 3 pages, right? But what I've done is I've put all of these functionalities into one. And then each of this, notice the remaining things, everything here is me calling this function. So when I call this single function, what it does is it runs through everything that is here in this one step. And then it goes back, runs everything that is here, and then goes back. Does that make sense? So you're creating a function of a function. That's all that's going on, right? A function of a function. So you can create functions and put those functions in other functions. All it does is that it makes your programming more compact, and it's able to do more things with fewer lines of code. So, and then here it actually showed you, they actually created a particular function that helps you run this stuff and download it as a GIF. If you try that, it'll be nice you try that. Let me just run this for those of you that haven't tried this. So run. So it runs. And then after that, it gives you this button to click save. And then you can actually literally save the GIF of this on your laptop, and you can click it and then it begins to run on the laptop. How was this able to happen? Very easily, because someone has written some kind of code, right? A function somewhere that's called start recording. Now that function contains a couple lines of code, right, on how to go save a GIF and store it. So all we've done is that we are just doing a function call here, that's all, right? And how are we able to achieve that? By just including this one line of code, which is just a function alongside everything that has been going on. And then look at, if I want to create a title, so for example, let's say I want to change this title. Just a minute. Oh. Now I'm trying to, I can't even move my screen anymore. Oh, I think my screen is hanging here. Can you still hear me though? Uh-oh. Yeah. So the screen is kind of hanging. Let me run it. Now it doesn't seem. Okay, anyway, I'm gonna stop with that. I wanted to show us one more one of those files, but this is not allowing me to end this. So I'm gonna have to shut this down and then continue with this. Okay, just a minute. I'm shutting this failure down. So can you see my slide? No? Okay, let me go back, use this slide. So this is the point I was making, that the bot's ability to dance is made possible by all of those functions, right? All we did is just arrange the functions, and the functions make calls to whatever files have those things, and then they begin to execute. So you literally make the Boji bot dance by calling the existing functions. These functions make Boji bot start, move, and change color. So that's essentially what goes on, and that's what the whole point of that exercise is. Because as you go through that exercise, it makes it like it begins to help you get comfortable with those functions. What you do later is literally, because the next task after that is to just decide, okay, what's going to be in those functions, right, that are going to create me that result that I want. That's it, right? So, and then I talked about the application programming interface, where I mentioned that a specific set of functionalities that can be used to accomplish a task. So notice, I put that in quotation marks, the set of functions. So it's a set of functions that are related to each other that control the Boji bot is an example of an API. So that's what we have there. So I'm going to so this is exactly what I just showed us. And then notice this, right? So literally all that's going on, this is the particular, before I was interrupted by the freezing of that laptop. That laptop, I have no idea why it decides to freeze on me. But so all that was going on there was this, right? I start the bot, then I do the title. All you need to do, if you want to change the title, click in, change the subtitle, all of that is going on there. But guess what? I can decide to go pick some of those, put them in this, create a new function. And then once I start running, it will come here, run this. But guess what? It now goes here. This is literally this repeated. This is literally this repeated, but I pull out all of that functionality by just putting a line of code, which is, so what you have here is what we call the function call, right? You're making a function call, a call to this function to run. So this is literally functions within a function. So the next part is, which is what I want us to, and this particular topic, I'm going to have to open my system again. I just restarted the system. I'm going to have to open it again. It's important if you haven't gone through this, because if you don't go do this, you might end up also running into some difficulty when we begin to do Xcodes. This is actually very important because I went through the exercise and it's essentially mimicking some of the things you're going to be doing in Xcode. And I'm going to show us what those are. So I'm going to stop sharing here and go back to my, so if you look at your files, if you can find data visualization, please try to open data visualization. And that's another API, application programming interface. But this application programming interface is dedicated to data visualization, right? So there are a bunch of related functions that have been put together that can help you develop, do data visualization. And three main things like those functions are able to help us do is build pie charts, build bar charts, and create scatter plots. And I'm going to show us one of those as an example here. And more importantly, I want to show the syntax, right? And how you actually enter the lines of code, because the system makes a lot of suggestions for you. So let me share the screen again. Am I sharing the screen or the window? Okay. Yeah. So I want to assume you have an insight in my window now. So data visualization. So if you're working with me, this is your set of folders. We go to algorithm, play with programs, data visualization, and double click. So that's what we have, right? So look at this. Let me go back one step and then we go through, right? So we've done the Boji bot playground, but then we are trying to do a second set of two. So we're trying to do a second set of an API that helps us do data visualization. So what do we have here? So I'll just read a bunch of things. So it says the visualization API allows you build a pie chart using the add wedge. These are like wedges, right? All you're doing is once you call this function, right? So notice these parameters, right? You have a couple of parameters. If you remember what we did, if you go through the exercises for functions, you'll understand how parameters are a part of your function. So you have parameters and then you have arguments, and you can, you know, input data, right? In your function call, you see the parameters can go feed data into the parameter line, and then the processes will happen, right? So these are examples of those parameters, right? So in this particular case, this function add wedge, and it's very intuitive, but because all it's saying is that we just need to add one of these wedges, right? But then I need two things. I need to know the proportion, in other words, what percentage of the circle it takes. And then the next thing I need to know is color, right? So I have my parameters. I just need to provide the value of, so is it 10%? Is it 5%? Then I need to provide the color that I want, right? So with proportion is the size of the wedge as a percentage of the whole pie. The number should be so it's written to be a double, not an integer, right? It's written to be a double between 0 and 1. But you're going to see the example even if you don't understand what I'm talking about right now. So you also have the color, and then from the color you can choose a bunch of colors, right, that have been included. And I think they created this with a data type that you call enumeration. That's something I don't know if we're going to be able to get to it today. If we don't get to it next week, we will get to it. But that's part of what I think is going on here. So this is an example of what we mean, right? So we are starting with make, notice this, make pie chart, right? So that's what we start with. That's like your start program, right? So I start with this, and I have all these wedges. Notice that I can decide, you know what? I'm going to add one more wedge. Copy. What color would you want? Maybe we use red. There's an overlap going on, so you have to do it in such a way that when you add up everything, it's supposed to give you what you might call it. It's supposed to give you 1. If you don't, it will overlap. So notice the 10% here, there's an overlap going on. So what I'm going to try to do is to change the proportion. So I'm going to change this to red, and now we have a red somewhere. Notice? So let me reduce. This is, let's say, 2, 3, 3 here. So that's 3, 3, 6, 7, 8, 9, 10. So we've got this complete. Notice how we've been able to increase this to how many wedges? 1, 2, 3, 4, 5. Each line of code gives us a part of that wedge. How is this possible? Just the functions, because someone has written these functions, right? And a function call is happening, right? So the whole idea of trying to walk you through all this process, right, in the beginning was to help you understand, okay, this is what a function is, this is how to write the functions, and now we are showing you how to use the functions. Because when you begin to work in your Xcode, all you're going to be doing is just calling functions, and things will be happening on the screen. And that's it. So let's say I decide, you know what, I just want 2 colors. Boom, and I cut this off, right? So these are the 2 colors. But then I need to fill it. So let's make this 6 and let's make this 4. 6 and then 4. Boom. So essentially, that's all we're doing here. So let me go back, make these 2, make these 2, and say bring back my other, right? And I run it again. So I can't emphasize enough, you know, the importance of, so notice, oh, there's some gap there. That means this doesn't add up to 1, 2, 4, that would be 7, 8, 9. So let's make this 2, right? I can decide all of those percentages and I get this, boom. So we move. So, but any questions though? Does anyone have any questions? Okay, so so all of a sudden we are introducing an extra function. What's the function, right? We want to include a label, right? So you have all these colors, but we don't know what they mean, right? How do I introduce it? All you just do is you go use something called with label, right? And whoever wrote that function, when they wrote the function, that's all they do. So you come here with label, and this is how you, this is the function, add key item, right? With label and color are the parameters within that. So you just copy this, because this is a call. You're making a function call, right? So you drop it, add label item. This is your parameter, and this is the value of your parameter. As you can tell, just by looking at this, you know this is a string, right? For color, this is what you call a case. Use a enumeration to create a case, right? But we're going to talk about that some more. And then you do that for each of them, right? Take each of the colors that are here and then represent them there, and that's how you get all of this. So my point being, if I want to add more functionalities to this graph, right, I just need to get a function that does what I want it to do, throw it in there, boom, I get the results. So where else? And then after that, we also go into bar charts. You can go look. We don't have a lot of time to continue with this, but these are this. So let me just do one more. Let me include one more bar chart there, one more bar, right? Let's say I'm going to make this longer than the others, make it 10. I think 10 is the maximum here. Yeah, and then I change the color to what's not here, blue. Boom. But so notice what's happening, right? As I type that, there's an auto suggestion there. That's the part I'm talking about. And all you need to do, once you get the choice that you want, you click your tab, right? And it chooses that option for you, right? And then I have my blue there. Because you're going to have a lot of that going on when you begin to do your Xcode. You're going to have these auto suggestions, right? And then when you get the also auto suggestions, if the particular method that you're looking to engage is somewhere down, use your down arrow to scroll to that point, and then you click your tab, right? And that's how you get on that. This will provide you a lot of practice with that. So let me see. So notice what, so this is this function, you're using this function to just add a point somewhere, right? Let's assume I'm trying to put a point at 10 where x is equals to 10 and my y is equals to 10. So to put a point there, it has to be somewhere here and somewhere there. How do I do that? I just copy this, right? And then I paste an extra line, right? And then I change this to my y to 10, comma, and I change my x to 10. Boom. But to make it more very obvious, let me change the color from black to red so that it will look different than others, right? Boom. So that's my point. I created that point, right? So again, it's very important that you go practice this. Practice, practice, practice. Why is this important? Notice what I do here now. If I click add point, did you see what I did? Let's assume I don't copy, because eventually when you're going to be doing your Xcode, you're going to, so if I know of a function, because you're going to get familiar with a lot of functions, right? But and a lot of the functions are going to look like each other. So the point being that if you now want to type to get one of those functions, let's say I start with add. Notice that there are two functions already there, right? There is the add point at XY and color. There's another function under beneath it that is called additive arithmetic, right? I don't know what that does. Let me go back. Add. So additive arithmetic, right? I just used my down arrow to go to it. If that's what I wanted to accept, I click my tab, right? And then my tab again, and then I've gotten my additive. I don't know what that does, but I'm just showing us. So practicing this would help you know how to quickly choose all of those things, because you're going to be dealing with all of that. So when I click, now I have the add point at X, Y, and color.
Right?
Yeah, I have that within my view because it's highlighted in blue. So all I need to do right now is I click my tab again, and it gives me this. Notice what's happening, right? So what it does is it's giving you the parameters, it's asking you to enter the values. But notice it tells you, hey, I'm expecting a double here. I'm expecting a double here, and I'm expecting color here, right? So a double can actually accept what do you call it, an integer, because in a sense it can serve. So I can say something, or let's assume I decide, hey, let me just use an actual double. I can say 34.5. See, that goes off, and then I use my tab again. When I click my tab, it jumps to the next value that needs to be. So you need to practice all of this, because that's what actually would help you code very fast when you begin to work in your X. But practicing a bit of this is going to be very helpful. So I clicked my tab, then I enter a value for my Y. Let's assume that I want my Y to be 9. So the next thing is, you see, it immediately accepts, and I click my tab, and the tab jumps over the color and it goes to color, and I click dots, and then it gives me all of the options, right? Did you notice that when I clicked my dot, it gives me all of the options? I can now scroll with my arrow to whatever option I choose. Let's say I want brown, and I click tab, and boom, everything is in place, and I can now run this, and all of a sudden that's my brown there. So this is the part I wanted to show us. You need to be able, and don't just copy and paste, begin the name of the function and see how all of that happens so that you can practice and practice, because as you begin to build those codes, those are the kind of things that will happen. You have a lot of auto suggestions, and then you see the system asking you to enter certain values. Getting comfortable with that off of itself is a skill. I think I'm done with this, except anyone has a question. Do you have any questions? If you don't have any questions, probably would take a 5 minutes break, and then we come back, and then we'll move into unit 3, I believe. So let's take a bit of a break. If you're down for it, take just a coffee break, 5 minutes, and then we will be back. So let's kind of try to get back here by 7, let's say 26, 25, 26, and I'm going to start off again. All right, people. Thank you so much. Okay. Oh, unfortunately, I think the recording stopped when the system went off or something. Okay, anyway, I will record the next session.